This is AP Calculus, lesson 6-2. We're talking about general particular solutions. Well, general and particular solutions. Where are we in our unit guide? So we are halfway done because we're on the second lesson, 6-2. We're still on standard and differential equations. Let's jump right in. So this is the setup. Go ahead and copy that down. Now that you've unpaused me. So what does it mean to have a solution to a differential equation? The last lesson in 6-1, we found that that was taking the antiderivative. But what does it look like graphically? So if I have a general solution of some differential equation, it will generally look something like this. You'll have a parabola. I already pre-drew that, I know, so fancy. And it will look like this. It'll be on a slope field, and maybe you just want to draw a slope field, but this is a general solution. But it could also look like, and let me move these around now, it could also be down here. It could also be up here. All of these are possible solutions. They are all the general solution. You have a bunch of these different graphs. So the general solution just has many of these different y-intercepts. And so the general equation then is you'll have some variable y or something is equal to some other variable. But the kicker here is it's going to be plus c. If it's plus c, then it's a general solution because you don't know how far up and down it's moving. You don't know what the initial condition is. So I should label this thing to this c. This thing is the y-intercept. Y-intercept. So the y-intercept can change. What is the particular solution? So the particular solution, let's go ahead and again copy our parabola. Oh no, here we go. A particular solution would be just one. We'll say there's that one solution. And it has, maybe, it doesn't have to be an initial condition that's there. It could have an initial condition that's right there. Maybe I should do that in red. Maybe this initial condition would say something like, it has to contain the point, I don't know, what does that look like? 1, negative 1. If it contains that point, then it is the particular solution. And then what is that going to look like? It'll be, again, something, usually it'll be a y, but I'll just say something equals some x variable, and then it'll be something along the lines of, I don't know, in this case it was plus, technically it was minus 2. You'll have a number here for the y-intercept. So these are the two different things that we're going to be talking about. How do I find the general solution equation, and how do I find the particular solution equation? Always be thinking about what that graph looks like when I'm writing this out. When I see a plus c, there should be multiple of these graphs. All right, so moving on, how do I find that general solution, the first part? So you'll have an equation that looks something like this, and I would like to note here that we have both an x and a y. Let's write that out. We have both x and y. And these variables are not on the same side. You'll notice that you have a y and an x and a y, so variables are mixed up. Variables mixed up. So because of this, we need a new strategy for how to solve this equation. And it's not really a new strategy. It's a strategy that you've learned before, probably in Algebra 1 or even maybe before that. And that rule, I'm just going to be calling it separate. I'm doing my major rules in red. That way it's easier for your summary to just pull them out like, oh yeah, it was that one, then that one. Although color coding it probably doesn't help that much. It's the number. So what do I mean by separate? It means I need this form. So I need some number over some number equal to another proportion. I'm setting two proportions equal to each other. And in this example, I did give us that same format, so we don't need to worry about this for this problem. But sometimes I'll just have maybe dy over dx equals negative x, and it's not over anything, so you just need to put it over 1 to get into this form. So once you get it into that form, and that's the form of a fraction, we'll say a fraction equals a fraction for our side notes, then we're ready to do the next step. So I'm going to actually be doing this problem on the right here in my free space so we can see how these steps apply. So we have that already. So it was a dy dx equals x squared over y. We have this form. And then the next part of separating the variables is to cross multiply. Whenever I have two fractions set equal to each other, that is usually what you do. So you cross multiply. That means that I'm going to multiply dy by y and dx by x squared, and you get the equation y dy is equal to x squared dx. Oh, my x got messed up. Dx. All right, and this is a final step that we don't actually need in this problem, but it sometimes happens. I would say like 50% of the time. And that is sometimes you still need to separate your x and y. X and y. Because sometimes you'll have like an x dy equals a y dx. And you'll have to move them so that they're on the same side. So I'll make a note here also underneath here that sometimes, or maybe not sometimes, but you only do this step if you have something of the form, we'll say like a y dx equal to an x dy, because you have a y here and an x here, and the way that you separate those is just to divide. You never add or subtract. And I'll make a note later, so I guess I can just put it right here. So just divide. I would divide both sides by x, I would divide both sides by y, and I would get them moved to the right side. We don't have to worry about that. We have everything on the right side. The y and y are next to each other, x and x are next to each other. All right, and finally we get to step 2. Step 2 is doing the actual solution, and that means I'm integrating. I'm taking the antiderivative. So this is integrate. So when I integrate this, that means I'm going to do the integral of y dy is equal to the integral of x squared dx. So when I integrate them, then this is going to become a y squared divided by 2, and that's going to be equal to my x cubed over 3, but I'm forgetting something, and this is something that we might forget, so I'll write this in the notes. Don't forget, you know what I'm about to write here, don't forget, yep, you know, plus c. So you don't have to put it on both of them, you only have to put it on one, and usually you just put it on the right. It's the standard, so plus c. Perfect. We have now just found the general solution. We have this graph over here. We have a plus c. All right, actually, before we move on, do I have everything here? I guess the one key thing for finding a general solution, the main thing here is make sure you have a separation of variables. So here is separation of variables. So I'm not writing that just for the sake of writing it. I mean, yes, we had to separate the variables, but why does that matter? It's because if you don't do step 1, you get 0 points on this whole question. Even if you do the integration right, you do everything right, which might not even be possible, but if you don't do step 1 correct, you get 0 points. So you can say step 1 equals wrong, 0 points. Make sure you know how to separate your variables in step 1. All right, so moving on to the next slide. Here's the setup. Go ahead and copy it down. All right, so you've unpaused me. So finding a particular solution, this is the second graph that we're on here. So finding a particular solution, now you just need to evaluate. And that's just a fancy word for saying plug in the x and y that I've given you. So I'll say plug in x and y. And for the homework, you're not doing any of this. Like the homework basically ends right here. You integrate, you add your constant of integration, and you're done. The homework tomorrow, you're going to be doing the same thing in addition to this evaluate step, plug in x and y. Okay, step 4 here is in green for a reason, because you don't really need to know this. I mean, it's great to actually solve the problem to figure out the full answer, but this is optional. I'll say that. This is optional. And that's because, I'll explain it down here, but generally what I mean by isolate, if I were to do this step, that means you get the y by itself. So get y by itself. All right, so The other note here, and I guess this is kind of a green note, it's not super crucial, and that is not needed to pass AP test. And the other note that I'll make here is requires lots of work and many tricks. I mean, for this guy, you need to know like how to restrict your domain. You need to know all these cool algebra tricks that we probably all forgot about. So I will be making another video just talking about step 4, but I'm not going to explicitly teach it in this lesson because I don't feel that it's needed, nor does John. John doesn't teach us unless you come in after school. So why is this not needed? So this is my quick little explanation. So we all know that a 3 is a passing score on an AP exam. You can get a max of 5 points. So FRQ stands for free response question. Each free response question is 9 points. So in order to get a 3, in order to get a passing score, this is how many points you need on each free response question. You need 3 points, and maybe I should make that in red. You only need 1/3 of the points per question in order to pass the test. And by the time you hit step 3, we usually will have 6 to 7 points. That means you have more than enough points to get a 3 on the AP exam just by hitting step 3 without having to do all of this extra work. And moving to the next slide, we have 2 examples. I'll do one example here and one on the next slide. So I'm trying to find the general solution of this equation. And note that you can't find the specific solution because I don't give you any point. I don't say at x equals 1, y equals 3. All right, so we're just going through steps 1 and 2. Step 1 is separate. So I need to separate the variables. I need to make sure I have this form. I have it. Now I need to cross multiply. So I cross multiply here and here. And that gives us an x dy equal to a 3y dx. Oh no, I haven't actually separated my variables. I have an x and a y and an x. I need to get them on the same side. And this is where that the separate x and y, that third step under step 1 actually happens. So now I'm going to divide, and then I should note here to never subtract, because this will be made by a student if I don't say this. So on this step here, never subtract. Always divide. So I'm going to divide both sides by x, so divide both sides by x, divide by x. And I'm also going to divide both sides by y, so divide by y, divide by y. So the x is going to move to the right-hand side, the y is going to move to the left-hand side, and my new equation is going to be dy over, whoa, don't know what's going on there, over y is equal to dx over x. Perfect. So I have separated the variables. Y's are on the left, x's are on the right. Doesn't matter which is on which side, but they need to be on the same side, y's and x's. So now I'm going to go to step 2. I'm going to integrate. So when I do that, so it's going to be the integration of, I guess it's really 1 over y dy is another way to think of this, is equal to 1, sorry, I forgot the integral. The integral of 1 over x dx. And hopefully you know that you can't do anything with fractional powers. So this is going to turn into y to the power of -1 dy is equal to the integral of x to the -1 dx. And y to the -1, that is just going to be the natural log of y. And here's something that's very important. In order to get the points, whenever you take natural log, this needs to be absolute value. This has to be absolute value. If you put parentheses here, you're not going to get the points for taking the antiderivative. So it's going to be natural log of y is equal to the natural log of absolute value of x. And don't forget your plus c. So we'll make a few notes here on the side just to say what we did. So here we had to get rid of fraction. Get rid of fraction. And always don't forget your plus c. So don't forget your constant of integration. And I'm going to write that down here because that's the formal name of this. This is called the constant of integration. So before moving on to the next slide, I do want to point out that I would love to go in depth on why you need absolute value. It basically boils down to a domain restriction, but if you want to ask me about why that's the case, go ahead and shoot me a text to let me know you're interested and I'll make a video. Moving on to the next slide though, our last example, this is the last slide and we're done. So our last example, find the general solution again. Again, I can't find the specific solution because I don't have any specific point. So I have this equation and note that it isn't in that fraction equal to a fraction form. So my first step is going to be writing this divided by 1. So now that I have that, I can cross multiply. So then I cross multiply, and I get 1 dy, or just dy, is equal to negative y dx. Note that we haven't separated the variables, so I need to divide both sides by negative y. So I divide that side by negative y, divide that side by negative y, and I get 1 over, you can say negative 1 over y dy is equal to dx. Okay, we have separated the variables. Y's and y's are on the left, x is on the right. Now we go to step 2, which is integrate. So when I integrate both sides, and that's easy to do, I'm just going to do this in a different color, let you know I'm doing this in a different step. I'm just going to add this integral sign. And again, we don't like fractions, so get rid of the fraction. This is now going to be the integral of negative y to the negative 1 dy is equal to, still integral of, I guess if you don't like dx, you can say 1 dx. All right, now I take the antiderivative. So y to the negative 1, that's just going to be the negative natural log of y. So it's going to be the negative natural log of absolute value of y is equal to, and then antiderivative of 1 turns into just an x. So x, and don't forget your constant of integration. All right, that's all I have. I guess I should mention this, that if you do the antiderivative of a constant, if you forget that, you can put it in the notes. So the antiderivative of dx will always be equal to x, I guess, plus c. Antiderivative of d, I don't know, q, any random letter is going to equal that letter, q, plus your constant of integration. That's all I have for the video, so go ahead and do your summaries now.